My name is Aseem. I'm an assistant professor of medicine in the Stravitz-Sanyal Institute for Liver Disease and Metabolic Health. For me, it's a great privilege to be part of the institute. The objectives, the goals, overall goals of this institute it's aspirational. It has the potential to transform liver health, liver disease in this country and worldwide. So we have incredible expectations and incredible hopes out of this institute as a member of the institute. So all in all, I'm very grateful to be part of the institute. I think what others need to know is that this is gearing up, and this institute is being set up for the long term, and to address some of the problems and the biggest challenges in the field of liver. So we are in the process of setting up ourselves to be able to best address those problems in the long run. For us, it's the center of everything in a way, and perhaps this is a biased sort of look at things. But yeah, and just the importance of it. Like I said, without your liver, you can't survive. There are other organs that we have ways of sort of overcoming that, but not for liver, not yet. So it's a very important organ, but it's also one of the few organs that regenerates itself so well. And at the same time, it has both simplicity and complexity, meaning, when you look at it histologically, it's not a very complex organ, but at the same time, the functions it has, the processes it goes through, it's very complex. My whole focus has been on cholestatic liver diseases, and more specifically, these are basically cholangiopathies, which are diseases that have one aspect in common, which is that bile ducts and the cells that line these bile ducts, they're called cholangiocytes, they're the target of the disease. And in a lot of these diseases are progressive, so they continue to progress. If in some of them we have treatments for example, primary sclerosing cholangitis, which is a prototypical disease for this group of diseases, which has absolutely no effective treatments even in 2025. So the commonality being that they're progressive, and then the other aspect of it is that they're also very fibrotic. So fibrosis, which is scarring in the liver and scarring around these bile ducts, is the common aspect of it. So my focus has been trying to figure out how that scarring, how that fibrosis happens. What are the signals? What are the cells that are involved in that? And how can we target those to prevent it, either prevent the fibrosis or reverse it? Preferably we'd want to reverse it, but that's a strategy in itself as well. So my goal has been to trying to figure out the mechanisms of biliary fibrosis around these bile ducts, and develop strategies that we can utilize to treat biliary fibrosis. Which, by the way, even though we have treatments, we don't have any specific treatments to reverse or treat the scarring, fibrosis aspect of liver disease. And this is specifically true for cholestatic liver diseases and diseases with biliary fibrosis. So this is a very, very much needed sort of treatments, but we really don't have any yet that's available. So that's kind of the focus of what I'm doing. But within that, with more specifics, we're looking at the cholangiocytes, cells that line the bile ducts. We're looking at how they signal, and we look at how we can activate these cells to start signaling and produce lots of signals. And then we look at, what are the pathways that we can target, that we can specifically knock down the bad effects, meaning the scarring effects, the fibrotic effects, and to an extent also perhaps the inflammatory effects. So once these cells are damaged, they kind of instigate inflammation, not just by themselves, but also from the immune cells that kind of come in and infiltrate that area of damage. So how can we stop that cycle of inflammation and scarring that sort of propagates? So there's different aspects of different projects that we have going on in the lab that look at different aspects of that process.